Okay guys, welcome to 6.6 Solving Radical Equations. This is our first online lesson notes that you're going to be taking. So I put this key concept box here because these are the three steps that you're going to follow each time you solve one of these radical equations. Number one, you want to isolate the variable, meaning you need to make sure, isolate the radical. You need to make sure nothing's being multiplied to the radical, nothing's being added to the radical. It needs to be alone, isolated, okay? Number two, you got to pay attention to the index because that's what you're going to raise each side to. So if it's an index 3, you're going to raise each side to the power of 3. And finally here, when you solve the polynomial equation, this is using techniques you've learned in previous chapters. Well, this is really going to be for equations, obviously because we're solving, and also quadratics you want to pay attention to because both of those are going to play a part in this section. So hopefully guys, you see this writing will get better as I work with this active slate a little more. Oops, I think I hit. There we go. All right, so I rewrote the radical equation. We're going to solve the cube root of 2x plus 7 equals 3. Now, first step, isolate the radical. Is there anything being multiplied to the radical? Is there anything being added or subtracted on the outside of the radical? So hopefully the answer for this you guys have is no. Okay, so again, what we can do right away is raise each side to the power of 3 because the index is 3. Okay, so I'm going to use brackets to help us. You don't necessarily need to, so everything's being raised to the third power. Okay, so now once it's raised to the third power, the radical simplifies out. So you're just going to be left with 2x plus 7, and that's going to be equal to 27. Okay, now we solve this equation, this two-step equation like before. You subtract 7 from both sides. Okay, and we'll be left with 2x equals 20, and so x equals 10. Now you always want to check these solutions. I'm not going to check this one because eventually you're going to run into some extraneous solutions, meaning you'll solve for x, you'll get an answer, and then when you check it, it doesn't work. So that's our first example here, the simplest form to solve this radical equation. So let's go into something a little bit different. Okay, so the second example here, you don't see a radical, we just see an exponent, which you're going to actually solve these the same way as you would any other radical equation. So we have, here's our problem. So again, something's being multiplied to this 3/2 power. It's 4. So we're going to divide everything by 4. Okay, so you're still going to have x to the 3/2, and that's going to be equal to 27, 108 divided by 4. Now, in order to get rid of a 3/2, you have to think reciprocal. What could you multiply by 3/2 to give you 1? Reciprocal of 3/2 is 2/3. So everything gets raised to the 2/3 power. Okay, so we're over on the 27, and it's to the 2/3. So now you're just going to be left with x is equal to 9. You can raise 27 to the 2/3 power. There's different ways to do that, but your answer is 9 here, and you can plug that back in and check it. 9 to the 3/2 times 4, in fact, does give us 108. The third example is when we're going to continue working with the rational exponent, but notice how you see there's a number being subtracted here. Nothing's being multiplied. So I'm going to rewrite our equation just so I can manipulate it because that's a picture. So we have 3/4 power minus 1 equals 7. So before I do anything, I have to add 1 to both sides. So now we're going to have x plus 2 to the 3/4 power equals 8. Okay? Now, to get the x plus 2 by itself, that base, all you're going to do is multiply everything by the reciprocal. So when you have a fractional exponent, we multiply by the reciprocal to make it 1. But this is an equation, we do the same thing to both sides. Okay, and this is where we actually have a little trick. So we're going to have x plus 2, and that's going to be equal to 8 to the 4/3. Okay, but we can actually rewrite this as 8 to the 1/3 times 4, or raised to the 4th power, excuse me. So you got to think to yourself, well, what number to the 3rd power gives me 8? 8 to the 1/3 actually gives you a power, gives you 2. So you're going to have 2 to the 4th, which is 16. So you have x plus 2 equals 16. So x equals 14. And that is your solution to that equation. Okay? Now when we get involved into the next equation, we're going to go back to radicals, and this is where you're actually going to see extraneous solutions. It's not 100% all the time that you're going to get an extraneous solution, but really this is going to end up being a quadratic equation that we're going to solve for. And so we're going to see an extraneous solution, and that usually happens when you have a quadratic, when you're solving a radical equation, and you get a quadratic when you start to solve this. So this is no index here, we don't see, so that's 2, so that means it's a square root. So here's where you're going to automatically see this quadratic. Applying our rules, you're going to have x squared plus 2x plus 1, and that's going to be equal to 7x plus 15. Okay, so let me just go ahead and rewrite this so we can see a little bit of x squared plus 2x plus 1 equals 7x plus 15. Hopefully that's a little better. Okay, same thing as above here, but this is just too messy to see. So now you got x's on both sides. Get everything to one side, everything you want. So you're going to have x squared, okay, minus 5x, and then minus 14 is equal to 0. So you go back to your factoring rules. This is a 1 in front, so you say what two numbers multiply to be negative 14, add to be negative 5. I'm going to say minus 7 plus 2. So these are your factors, they're not your zeros. So x equals 7 or x equals negative 2. So now this is where you check them. Now I went ahead and looked at which one's going to be extraneous, and it looks like negative 2 is going to be. How do we know? Well, let's plug it back into the original. Should work, right? Negative 2 should work. So you have negative 2 plus 1. Does that equal 7 times negative 2 plus 15? Well, does negative 1 equal the square root of negative 1? It does not. That would have to be I, but it doesn't. So we can't take, we know that the square root of negative 1 is I. Negative 1 does not equal I. So that would be an example of an extraneous solution. And notice how we had a quadratic equation where that popped up. It doesn't always happen with a quadratic, but most of the time it does. Now this one is our hardest problem, because now if I subtract 1 from both sides, because step number 1, remember, is the radical by itself, get it by itself. Well, I have radicals on both sides, so if I subtract 1, doesn't matter, I'll just be ping-ponging back and forth this 1, and we'll still never have a radical alone. So you really just have to bite the bullet on this example and just go ahead and square both sides. Okay? So the right side, obviously, fortunately, is going to be a little bit easier. However, applying our rules, we're going to take this x, you're going to have the square root of x plus 2, and you're going to go ahead and perform our rules. So this actually just becomes x plus 2, our rules of a plus b squared. So this is x plus 2 plus 2 root x plus 2 plus 1, and that equals 3 minus x. So if you don't know how to do this, I would suggest that you use the box method. and you'll be able to do it. So we can clean this up a little bit. X and 2, and you have 1 over here. So you're actually going to have x plus 3 plus 2 root x minus 2, or excuse me, x plus 2 equals 3 minus x. Okay, so we can get rid of some of these terms. Okay, so we can subtract the x from both sides and subtract 3. Okay, so we're going to have 2 square root of x plus 2 equals negative 2x, because the 3's will cancel. Now, again, you have a radical not by itself. It's being multiplied by 2, so you divide everything by 2, and you're going to have the root of x plus 2 equals negative x. And now, to get the radical by itself, you square both sides. So we're left x with x plus 2 equals x squared. Let's go up here. And so bringing everything to one side, you're going to have x squared minus x minus 2 equals 0. And now you factor this, two numbers that multiply to be negative 2 and add to be negative 1, or x minus 2, x plus 1, that equals 0. You're going to have an extraneous solution here, x equals 2 or x equals negative 1. So your extraneous solution here is actually 2. So your only solution would be x equals negative 1. Okay, so that is how we solve radical equations. I hope this helps. If you have any questions, make sure you bring them to class next time. Thanks, guys. Bye.